Chelsea?
101.
Disagree.
Brian, what did you get?
10.
Disagree.
JC?
111.
Agree.
Okay. Who wants to try to explain how to get the answer? All right, JC?
I know that 80 and 20 is 100. And then I knew that 6 and 4 was 10. So I took the 7 and 4, and that made 11.
Okay.
Agree. That's how I did it.
You disagree with yourself? Which do you think it is now, Brian?
111.
Okay, Chelsea, what about you? Do you still think it's... Okay. Let's go on to another.
Let's look at how our children invent subtraction in problems such as this one.
See? Eighteen. 11. Carrie Lynn, come here. What'd you get? Okay. Okay, got that one?
9.
Okay. Have that one?
11.
Okay. All right. Anyone else? Okay, I'm hearing a lot of 18 and a lot of 11, and a lot of people are saying the answer is 9. So we have 3 more answers again. Does someone have something we don't have up here? All right, how many think it should be 18?
I can prove it. I can prove it's 9.
How many think?
I can prove it's 9.
All right, how many think it should be 11?
It's not
2? How many think it should be 9?
I can prove it's 9.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I can prove it. I can prove it's 9.
Okay. Gary, we'll let you try first. What do you think the answer is?
See, you take what the last answer is. 9.
Okay.
See, you take, like I did last time, you take the 6 and the 7 off the 17.
Okay.
And then take off 10, and that will be 10. And take off 7 more, and that will be 3. And add the 6 back on, and that will be 9.
Okay, so 20 take away 10 was 10. You do.
I can make it.
What was your answer?
It was 18.
18. All right, Elizabeth.
I took 10 off the 20, and that was 10. And I took 6 off the 7, and that was 0. And I took 1 off the 10, and that was 9.
I can prove it's 11. 20 and 10 is 10, and 6 take away 7 is 1, and 10 and 1 is 11. Disagree.
So Stephen has a different answer. Stephen says 20 take away 10 is 10. And he says 6 take away 7 is 1. And 10 and 1 is 11.
Disagree.
The explanation of the next child, Grace, is impossible to follow. But when children try to give an argument that will convince somebody else, this thinking in itself helps them learn arithmetic.
You can't take 20. If you took 20 away from, you had 20 and you took away 10, how could it be 11 because you're taking 10 away? I can tell him. See, Stephen, you'd have to have 21 take that 21 away with the 10, and you'd be taking away 11.
Grace, you don't disagree. You know, I'll prove it's 9. I'll
prove it's 9.
Stand up. All right, Chris.
All right, you see? Stand up. Me too.
You see, 10 take off from 20 is 10. All right? And then add a 6 on it, 16. Minus 7, it's 9.
I can prove it's 9 too. I can. Everybody that thinks it's 9, stand up.
Now, Stephen, what did you do?
I know.
I disagree with myself.
You disagree with yourself?
I know.
Are you sure? You sure you're not right? You sure it's not 11?
I'll explain.
Okay, Tracy.
All the children subtracted 10 from 20 first. However, they dealt with the ones in 3 different ways. Elizabeth said that she could subtract only 6 from 6, and therefore had to subtract 1 from 10. Gary subtracted 7 from 10, and then added 6, but Chris added 6 to 10, and then subtracted 7. Stephen's answer of 11 is familiar to all teachers who have taught subtraction of this kind. Piaget said that if children make errors, they make them because they are intelligent and think. The teacher's job, therefore, is not to correct the children from the outside, but to create a situation in which children might correct themselves. Piaget's theory about the nature of logical mathematical knowledge convinces us that children are bound to arrive at truth if they argue long enough. This is why we bring out wrong answers and encourage children to exchange points of view. Whether they are right or wrong, children construct knowledge more solidly when they are encouraged to defend their ideas. If they become convinced that another idea is better, they will change their minds. This is why the teacher refrains from saying that an answer is correct or incorrect, and instead encourages children to agree or disagree with each other.